Let's do one more example of similar type. This is asking us to find relative extrema and saddle points of the function. Use the second partial derivative test where applicable. So as usual, we're going to start by finding fx, the derivative of f with respect to x, and I will get 2y minus 1/2 times 4x to the power 3, which is equal to 2y minus 2x cubed. I said it equal to 0, but it doesn't solve already for one variable, so I'm going to go ahead and call this equation 1. Similarly, I find fy, and I get 2x minus 1/2 times 4y cubed. So this is 2x minus 2y cubed. Set it equal to 0 and call it equation number 2. Now pick any one of these two equations. So if I choose equation 1, I will say solve this equation 1 for the variable that is easier to solve, and clearly it's y. So solve for y. And what I will get is 2y equal to 2x cubed. So dividing both sides by 2, I get y equal to x cubed. Then use this newfound value of y. So use y equal to x cubed in the other equation, in equation 2, and I will get 2 times x and minus 2y cubed. Remember, your y is x cubed. So I get 2 times x to the power 3 whole to the power 3 equal to 0, which means if I factor out 2x, I get 1 minus x to the power 8. 3 to the power 3 is 9. If you factor out one of these x's, you get x to the power 8. So that implies either 2x equal to 0, which means x is equal to 0, or 1 minus x to the power 8 equal to 0, which means x to the power 8 is equal to 1. So I take the 8th root on either side. I get 8th root of x to the power 8 is equal to the 8th root of 1. So I get absolute value of x equal to 1, which gives me two solutions. Either x equal to 1 or x equal to negative 1. So in this problem, I have a bunch of different critical points. So I'm going to write them as critical points and use the work we have produced so far. X I found to be 0. Then remember, y was x cubed. So this is going to be 0 to the power 3 and hence 0. So one of these critical points is 0, 0. X I found 1. Y equal to x cubed means 1 to the power 3, which is 1. So 1, 1 is a critical point. And finally, I have x equal to negative 1. So y equal to negative 1 to the power 3. That's negative 1. So the critical point is negative 1, negative 1. So we will do the second order partial derivative test, but this time we're going to do it for all three of these points. So I will go ahead and find out what is fxx. Let's go back to fx and derive it with respect to x. My fxx was 2y minus 2x cubed. If I derive it with respect to x, I get. So when we take the derivative of fx with respect to x, we get minus 2 times 3 times x squared. So that's minus 6x squared. Similarly, fyy is going to be, so we'll go to fy and take the derivative with respect to y. So that will be minus 2 times 3 times y squared, and that's minus 6y squared. Fxy is going to be derivative of fy, but now you take the derivative of that with respect to x. So this is my fy. I take the derivative of this with respect to x, and I get 2. So I'll go ahead and say that this is 2. So since I'm going to try 3 different critical points, I'm going to find out D'Alembert in terms of variable first. This is fxx times fyy minus fxy whole to the power 2. So I get minus 6x squared times minus 6y squared minus 2 squared. and that is 36x squared y squared minus 4. So what I do now, I say for my critical point 0, 0, let's test D. So D at this point is going to be 36 times 0 square times 0 square minus 4, which is a negative 4 less than 0. So 0, 0 is a saddle point. As soon as you found it, you are going to find out the value of Z. Remember, Z is f of 0, 0. So in place of x, you put 0, y, you put 0 in the original function. And the original function was 2xy minus 1 half x to the power 4 plus y to the power 4 plus 7. So I get 2 times 0 minus 1 half x to the power 4, so 0 to the power 4 plus y to the power 4, and then plus 7. So what I get? I get 7. So I say 0, 0, 7, this triplet is a saddle point. Answers my first critical point. I have to do 2 more, 1, 1, and negative 1, negative 1. For the critical point negative 1, negative 1, my D value is going to be, so remember fxx times fyy minus fxy whole squared was 36xy squared minus 4. So you say 36 times negative 1 squared times negative 1 squared, 1 for x, 1 for y, minus 4. So that's 36 times 1 minus 4, which is 36 minus 4. That's 32 greater than 0. So I go ahead and say that because D is greater than 0, we'll check the sign of fxx. And that at the point negative 1, negative 1 will be minus 6x squared, so negative 1 squared, and that's minus 6 times 1, so negative 6, which is less than 0. Hence we have relative maximum at the critical point negative 1, negative 1. So we are interested in Z now. Z is f negative 1, negative 1. So 2 times negative 1 times negative 1 minus 1/4 negative 1 to the power 4 plus negative 1 to the power 4 plus 7. So I get 2 minus 1/4 times 1 plus 1 plus 7, which is 2. 1 plus 1 is 2, so that's minus 2 over 4, so that's minus 1/2 plus 7. 7 plus 2 is 9. Minus 1/2, I can write it as 18 over 2 minus 1/2, which is 17 over 2. In fact, I think this was 1/2. I kept writing 1/4, yes. So that should be 1/2, which changes the calculation a little bit. And that's it. In fact, I think my answers are going to be better looking now, as instead of 1/2, we will have negative 2. I just miswrote that term, so I get 2 minus 2 plus 7, which is 7. So now you get to say negative 1, negative 1, 7 is a point of relative maximum. We have one more critical point that we're going to take care now, and that is 1, 1. Again, you are finding D at this point, which is 36 times 1 squared times 1 squared minus 4. So that is 36 minus 4, 32, greater than 0. So we find the sign of fxx at 1, 1. I still get minus 6 times 1 squared, which is minus 6, and that's less than 0. So this is also a relative maximum. And we are interested in Z now, so I do f of 1, 1, which is 2 times x times y minus 1/2 times x to the power 4 plus y to the power 4 plus 7. So similar calculation, you get 2 minus 1/2 times 2 plus 7. So you get 2 minus 1 plus 7. and that is equal to 8. So did I make the same mistake one more time? Yes, I think so. I said this is 2 for the critical point -1, -1. You should go ahead and change it to 1. So this is 1 plus 1 is 2, 2 over 2 is 1. So this is 2 minus 1 plus 7, which is 1 plus 7, and that's 8. I'm so sorry for making the same mistake over and over, but this relative maximum is -1 comma -1 comma 8, as well as the third critical point has given me a relative maximum at 1 comma 1 comma 8. So I'm going to go ahead and say that the point 1 comma 1 comma 8 is also a relative maximum. So we found one saddle point and two relative maximums, hence there is no relative minimum for this function. And I'm going to finally put these answers in. So we will say relative minimum, there doesn't exist any, so D and E. Relative maximum for smaller x value will be, of course, the -1 comma -1 comma 8, and larger x value relative maximum will be 1 comma 1 comma 8. Saddle point will be 0 comma 0 comma 7, and that would answer my question. In our next video, we're going to talk about Lagrange multiplier.